Okay, let's start the virtual contest. I'm doing Codeforces round 1076, which is a Division 3. First of all, like I'm very new to even Codeforces. I just, you see, like I don't even have a rating. Uh, yeah, that's it. Um, let's start. There is some issue. Oh, I think I already started the virtual contest some time ago. You see, it's running. Nice. So let me start. I'm not very much confident on things as like I'm just starting out. Let's see. DBMD had a birthday yesterday. He was gifted an array of n elements. Just a second. I'm setting few things up. I hope this is all visible. I'm actually using Google Meet and another device as Scratchpad so I can show you what I am thinking. I'll keep all of these off. I'll pin this. Okay, I think this looks better. Let's continue. Let me open Paint. DBMD. DBMD had a birthday yesterday. He was gifted an array A of n elements and a number x, but there is one problem. He only likes arrays where the sum of the elements equals s. To make the array appealing to him, you can perform the following operation in any number of times. Choose an index I and add x to the number ai. So for example, he is given the array 1, 2, 3, 5 x equal to 2, index 3 and get the array 5, 5. Your task is to determine whether the array can appeal to after any number of operations. Each test consists of several test cases. The first line contains a single integer t. The number of test cases, the following describes the test case, contains three integers. No s x contains an integer. Only likes arrays when the sum of the elements equals s. Okay, so let's check the test case. So here we have 6 out of which let's consider the first test case 3, 3, 5. Mm, so here the array is 1 comma 1 comma 1. So what do we have? So n is 3, which is we have 3 elements. Next, uh, x, he only likes arrays when the sum equal to s. So we have s is equal to 5 right now, and x we have as 3. To make the array appealing to him, you can perform the following operation any number of times. Choose an index I and add x to the number ai. So it's like we can choose any index and add x. So let's say if we do that, it becomes 1, 4, 1, and the total is going to be 6. So let's see this individually without doing anything. The sum of the array is 3, and when we add 3 plus x, we get to 6, which is greater than 5. So I'm assuming equal to s. um, nx is, oh my bad. So the order is nsx, not the reverse. So this is s and this is x. So as the sum is already 3 and our s is equal to 3, we need not do any operations. Let's see the second test case. 3, 8, 2. For clarity, let me write nsx. So, and the elements are 1, 2, 3. So let's see the total sum. 3, 4, 5, 6. You see, let's see few more test cases. And right now, like if I add s- uh, 2x to this, so if I write, actually I can add this x anywhere, right? And at the end of the day, anyway we are choosing a number, choose an index x. You can perform the following operation any number of times, means we can add x to any of the index any number of times. So it's like the sum of the array plus some, let's say t times, we are doing t times of x must be equal to s. So it's just we need to think s minus the current sum of array must be divisible by x, right? Let's check this with few other test cases. uh, I'll clear this for now. How do I delete this? Let me just move this down. Let me continue. So let's go further. N, this nsx 472. So the array is 1 1 1 1. um, we wanted grand total of 7 and we have 2's here, so the sum is 4. So let's say if we add another 2, that's going to be 4 plus 2 6, and even if we add another 2, it's going to be 6 plus 2 8, but it's never going to be 7. So I'm assuming this test case the answer is no. Yeah, it is no. Let's test it out for this. 3 15 1 nsx. So here 2 4 10 are the values we were given. Let's add this equals to 16. As the sum is already greater than s, it's no way possible for us to add more and get the sum, so it's a no. So we see that is a no here. And next, nsx 2, oh sorry, 205, yeah. So the array are 4 6, so this is 10. Okay, so now see, we can keep adding 5s so many times. So let's say if we add 5 for 18 times, then we would get 90 in the sum. 90 plus the current sum will result in 100. So this is going to be yes. And we'll be checking this in ways like, after taking the input, we'll do sum of the array. We'll have it in a variable called SA, assume. So we have S anyways. S minus SA should be greater than 0, and this value S minus SA should be divisible by Rx. Uh, that's the thing. Next, let's try out uh, 4 6. That is done. Let's try out our last test case. 5 12 1. The array is 1, 2, 2, 3, 2. This is 5 and this is 5 total. This is 10. So see, our S is 12, SA is 10, and X is 1. Let's use this formula now. S minus SA is 2, which is greater than 0, and S minus SA 2 is divisible by 1. So yeah, this is yes. So out of all this, we came to a conclusion that finally, so we were given NSX. N is the number of elements of an array. S is the final sum we want to achieve, and like X is the increment we can do on each element. And then we were provided with the elements of the array. So what we can do is find the sum. Here it is 6. So we can call this SA. Um, we'll do S minus SA and see if it is greater than 0. Yeah, this is greater than 0. So one condition is passed, and next condition is S minus SA must be divisible by X. So in this case, 2 is divisible by 2, which is 0. This is also passed. So this is yes, that's our approach. We have seen it break in case when it's a no, and we have seen it work in cases when it's uh, right. So let's just code this now. I'll copy the whole input. What is this called? BDMB and the array. And this is my DSA problem sheet. I maintain it every time I do some sort of coding. DBMB and the array. I think this is math. Okay, let's do the code. DBMP and the array.cpp. Let's get the boilerplate code from some other code I have. We can just use this. Remember, we have the input as this. Let me get that for reference. And also the output. Okay, so this I just felt like doing. There is no requirement of this. I just don't want to go back and forth. So n is the one the number of test cases, or let me name it as p, because I got habituated with NSX later. So here what I'll do is, why am I getting suggestions and all? Okay. File. My God, I don't want these suggestions anymore. I just don't know. I'll just have to ignore them. I'll do the changes later. So each time I need to take different inputs. So one is uh, N, another one is S, another one is X. So I'll take them in. I'm just seeing N, S, and X. And next I need to take the array. So what I have to do, like actually I don't know how to take array of input in C++. Let me just check that. C++ take input. Wait, I don't need an array now. I don't need an array now. I'll be a little bit smart here. I don't need individual elements. I just need some of the individual elements. So I can take a temp variable and SA, which is sum of the array. So for what I'll do now is for uh, so here while n minus minus, I'll just take C in temp SA equal to SA plus equal to temp, which is the sum. Uh, so if now it is our condition to check things. So remember our condition. It's one thing SA equal to S minus SA must be greater than 0, or what happens greater than or equal to 0 actually. So uh, let's say like even let's say this was 4 and we got 8, so the condition got satisfied, right? So S minus SA is greater than or equal to 0. So we can think of this way. So if S minus SA is directly equal to 0, we can directly say yes. If S minus SA is greater than 0, we need to check another condition of S minus SA is divisible by X or not. So the let's do these two cases. If S minus, sorry, that's a small s. S, oh my God, these suggestions are very distracting. S minus S a double equal to 0. Uh, how, how is the S? All capitals. C out. Yes. And L. Else if S minus SA greater than 0. So that's one condition. I'm getting the perfect suggestion. So see, one condition is this S minus SA greater than 0. Another condition is S minus SA mod X is 0, which means S minus SA is divisible by X. Uh, I'm putting more brackets just for more clarity. So if these all doesn't happen, where is the whiles else? This is all getting out of hand. While n minus 1 and minus minus, I have added all of those. I did the sum. Now I'm checking the sum. So if case and else case has done. So else, yeah, if it's not these two cases, then that's a no. Let me try to run this with this input g plus plus. Oh, is it in the same folder? No, cd personal 001. Yeah, now it is. Clear g plus 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 dvmd dot slash a dot dot. Now it's waiting for the input. Let me copy and paste. Oh, what happened? 1, 2, 2, 3, 2. No, yes, no, 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 no. Something weird happened here. If s minus s a greater than 0, let me just print few things. See out s s a x. Let me give the input myself. 6, that's 3, 3, 5, 1, 1, 1. No, but why are you not printing? Because I haven't compiled it again. 6, 3, 3, 5, 1, 1, 1. See, I am printing S, which is 3. SA, why is SA? Oh, I made some mistake. SA is 2 and X is 5. Why is SA 2? Temp, C in temp, SA. Okay, let me initialize SA to 0. Could that be an issue? Let me stop this, compile it again, run it again. 6, 3, 3, 5, 1, 1, 1. See, yes. So if I don't initialize, it will take a garbage value. 1, 2, 3. Yes, which is expected. 4, 7, 2, 1, 1, 1, 1. No, which is, yeah, right, as expected. 3, 15, 1, 2, 4, 10. Which is no, which is right. 205, 4, 6. Yes, which is right. 5, 12, 1. 1, 2, 2, 3, 2. Yes. So let's submit this. Uh, so here I can choose the file. Oh my god, language. C++. Where are you? I think this is it. I have no idea, but let's try. Desktop work. 100x DSA personal Codeforces. So I took like 22 minutes to solve this. Wrong answer on test 1. Oh, I forgot to comment it out, or I mean just comment it out. My bad, my bad, my bad. It's accepted. Now let's see. Reverse a permutation. This looks different. One minute. Mm, Okay. Now that's clear. Let's read out what this problem is. It's called reverse a permutation. A permutation of length n is an array consisting of n distinct integers from 1 to n in arbitrary order. For example, 2, 3, 1, 5, 4 is a permutation, but 1, 2, 2 and 1, 3, 4 are not permutations. Let's read that again. 1, 2, 2, 1, 3, 4. Okay, 1, 2, 2 and 1, 3, 4 are in ascending order. A permutation of length n is an array consisting of n distinct integers. I understand 1, 2, 2. It's having, it doesn't have distinct elements. What's wrong with 134? Like 134 is also a possible permutation, right? In arbitrary order, what do you mean by arbitrary order? Okay, we have an example. 2, 3, 1, 5, 4 is a permutation, but are not permutations. You are given a permutation p of length n. You can perform the following operations exactly. Choose two integers cell comma r, reverse the segment L to R in the permutation. So your task is to output the lexicographically minimum maximum permutations that can be obtained by performing this operation. A permutation A is lexicographically greater than a permutation B if the first position I where they differ it holds A of I greater than B of I. Bi. Your task is to output the lexicographically maximum permutation that can be obtained by performing this operation. Uh, your task is to output the lexicographically maximum permutation. Choose two integers L, R. Oh, we can do this operation only once. We have to output the maximum permutation That is, okay, each test consists of several test cases. The first line contains a single integer t, the number of test cases, the description of the test cases following. Each test case contains and next its elements is guaranteed the sum of the values of n across all test cases does not exceed sum of all. Okay. For each test case, output the lexicographically maximum permutation that can be obtained with the operation. So here for the first test case, the best segment is 1 comma 4 after reversing 4132. Segment is 2 comma 3 after reversing 321. After reversing a equal to 321. Okay, let's see. I have no idea on how to approach this. I'll just go whatever comes to my mind. Um, so, my bad. Yeah. So we have four test cases, and let's focus on the first test case. We have 3, 2, 1, 4. These are the elements of the array. So what we ideally want to do is choose a L. One second. Choose a L, choose a R, and swap this. I mean, swap in the sense reverse this. So 4, 1, 2, 3. If we swap this, so here lexicographically large, which just means it's the highest thing. So of all these numbers, 4 is the highest, right? So we want 4. Even if we want even more, we can have the best is 4321. We can't produce any number or any order bigger than this using only these numbers. So this is the highest, but remember, like, we need to do this operation only once. So if we choose L and R like this, this will be our best outcome. So let me just remove this part. Uh, okay, so this is one test case. Let's see others. I still don't have an idea on how to do this. 3, 3, 1, 2. I'm trying to uh, watch the test cases and try to find a pattern here. So now we have the maximum already here, but here uh, the maximum is not there. So we can consider L as this and R as this, and if we swap them out, we'll get this. This is the uh, the whatever the highest thing, the answer basically. Um, Next, 4, 4, 3, 2, 1. You see, like, this is in descending order. This is in descending order. So we need 0 operations. So this is exactly going to be the same. So let's write out the rules. I thought I did charge my laptop, didn't I? Okay, now it's fine. So now let's write the rules we got till now. So if descending order, leave it as it is, zero operations. So if we have a certain part of it in descending order, as in this case, as in second test case we have 3. What we do is we do the same operation we are going to do for the whole, for this part of list, uh, and see out how it will happen. What next? Let's try out the last test case. 2 2 1. Yeah, this is already in descending order, so no operation is needed. We'll output the same thing. So what other lessons do we have? Uh, so let's analyze this more. We have 3 2 1 4. We have the maximum at R, and ideally I'm assuming whatever maximum we have is going to be the R if it is not already in the first place. Uh, okay, let's take a case of few random numbers, 3 2 5 1 6 4. So here you see anything that comes with the highest 6. So this has to come here, which means our L is definitely going to be 3 and R is definitely going to be 6. So from here, what's the conclusion is maximum number is the R. L is always going to be the 0 index. Am I missing something? Let's take few more test cases and see, or let's apply these rules for the first test case. So 3 2 1 4. Let's have L as 0 and R as the maximum number. If we swap those, we'll get 4 1 2 3, which is our answer. And here I'm assuming the answer should be 6 1 5 2 3 4. uh, do we have anything else? L is 0 maximum. So something like this, let's see something like this, where the maximum is already towards the left. um, so what I'll do, okay, I'll take an example. So we'll consider 3 examples, all in different cases. One, the maximum could be the left side, the maximum could be the right side, the maximum is somewhere middle. So left side, let me write, I should write something smaller itself. 6 5 4, or I'll write 3 4 5. I can't have it again. Let me write 1. Okay, so here you see, um, this is already maximum, and this part, this sub part is in descending order. So we need to ignore this. Whereas for this, we'll need to do the same operation where we'll swap 4 comma 3. So this becomes 4 3 1. So this becomes 6 5 4 3 1 as the final answer. So here our choice of L should be this. and choice of R should be this. Uh, so if we see the maximum in the start, we'll break the list into parts where we have the segment of uh, the one in descending order is removed, and whatever the operation we do is performed on the right part. So that's one case. So here we want 6 to be in middle, which is maximum, and we see 3 4 6 5 to 1. So if it's in the middle, the case is that uh, we definitely want 6 to be coming here. So which means we have no option other than choosing L as 0 and R as whatever the index of 6 is. So in this case we'll have 6 4 3 5 2 1, and next having 6 at the end, or whatever the maximum number is. So let's think of 1 2 4 5, or 5 I'll write here. I'll make it 3. Um, 5 I'll write here, 3 4 6. Okay, you see here again we want 6 in the first place, so we have no option other than choosing L as 0 and R as this. So the concept here is, if it's getting clearer now. It all depends on where the maximum number is residing. So in the list, I'll just take an example. So if we have some chunk of it, or the entire, if entire thing is descending, print it as it is. Uh, if else, else we need to choose the part of it that's deciding. So let's take A, B as indices. We need to find up till where AB is, then we have to give the remaining part to another function. What this function does is, so this one will be similar to this or this, right? Definitely. So if we consider 3 4 1, it is similar to this case. The maximum is in the middle, so L is 0, R is 1. We'll swap this out. 4 3 1 will return this, which comes back here again, thus resolving in this answer. If we have this directly, else if this case where we have some part of it as uh, some part of it as descending, we do this. And else is this case where this similar case where we send the whole array and to this function. So what this function does is, so what should this function do? So the input of this function is a array something of this sort, or something of 3 5 6 4 2 1. So what it has to identify? It has to identify where the location of the maximum element is, and it has to swap it out with the least element. So 4, 3, 1 should be these answers. 6, 5, 3. Swap it out means, I mean, the reverse operation we talked about. So this is it. Let's try to code this. This will be a bit harder to code. I don't have so much experience with these things as I'm literally starting out, but you must appreciate me for my willingness to try these out at this level. I'm just going by my uh, way of breaking down things, just like a very brute force approach, reverse a permutation. Reverse a permutation. And I'm gonna be asking a lot about syntax. And earlier, I guess for the previous question, I got suggestions just because I have copy copy pasted the input and output. I'm not going to do that now. Let me do this. So let me get the boilerplate code. I don't want to do this part. And here it's a completely different thing. Let's it's t test cases. Yeah, do that. Here also it's t. Now inside this everything is different. Now let's see. We have n as input, int n, cnn. Um, it's giving me code to read an input of n in an array. I think that doesn't hurt. I don't want all of this. So here I'm not cheating. These are basic stuff. I anyway need to Google these again. So this is taking input of an array. Now what I need to do? I need to decide if it is already in descending order or uh, if some part of it is descending. So I'll do that while taking the input itself. So I'll have it two variables, int current number. Wait, int current index max comma max index. I don't know why I'm taking these many variables. Let's see how to play this out. I I just don't know. Okay, let's see. Uh, and I'll have a bool where uh, which is like is descending equal to true. I'll have it default as true, and I'll have break index, which is the one that points where did it break the descending pattern. So see, I'm taking the input as array of I, right? I'll have the same value in current equal to array of I, and let me initialize these things at 0 just to be cautious. And I'll keep incrementing the current index value, or current index is just I, right? My bad, I don't need this. uh, so max index is by default 0 if current greater than max, max equal to current I, max index equal to I, that's a correct thing. In the else case, wait, 1 second, I lost my thing. Let's say we have 3 4 and then 6 came. If we have everything in descending order, let's have it like this. Current equal to max equal to, what do I do? Array, just stop giving me these suggestions. I hate this. See, I'm taking input of the array and I want to know if it is descending completely or if it has broken somewhere. So let's assume the input is 35641. So it takes 3. It assigns current as 3 and current as greater than maximum, so it has 3 in it, and max index as 3. Let me just try these things out. Instead of see out, I'll give current max index break index. I'll give you inputs and test it out. What would I lose? See, reverse. C in a P nano, bro. It's T now. Dot A dot. So I'll give only one test case, and in that 5, and in that 3, 5, 6, 4, 4, 1. So you see, what is this? Current. Oh, current is the last value, so we have 1. I have max and max index. What else do I need? So I think that is it. So let's take the case of it is uh, descending till certain point 654 65241. So it's deciding descending till 2, then oh my god, my bad, that's not the output format. Let me 1, then n, then the value 65241. You see, uh, max is 6 and max index is 0. That is good. But here I need the index where it is breaking. So you see, from 2 to 4 this is breaking. So till here this is descending, but I want index of this uh, to be recorded so that I can use it. Break index equal to I. I'm assuming this would work fine. I minus 1, if I'm right. If I'm right. Let's see. I want index of 2 here. Let's do this. Input 1 5 6 5, descending till here, and now ascending again. Okay, let's see. We have the final value, 6 is the maximum, that is correct. 0 is its index, that is also correct. I'm getting 3 as the index. Why is 3 as the index? Current greater than maximum. Uh, how do I get the why did I get 3? Okay, let's try it out. Uh, why did I get why did I get the right? Why did I get 3 there? So I got 6 as input. Current is 6. Current greater than 6 is 0. Max and max index happened there. Next 5, which is again current. This condition haven't satisfied. Else, oh, if I get 5, then the index would be 0. I want a case where the previous is lesser than the next one. So I need another previous variable to keep track of my previous one. Is that right? Uh, Let me read the question again. Let me give another form of output here. 6, 2, 5, 4, 1. Oh my god. 1, 5, 6, 2, 5, 4, 5, 4, 1. Oh, the break index is not doing anything right. So it just gives 3 every time. So how do I find that it breaks? It breaks when it starts to ascend. It starts to ascend. Um, this is max. I want to know the index when it starts to ascend, when it starts to increase. I got the max index. If he's descending true, I need to check that. I definitely need to get the index of break index. How do I get it? I need to find out if somewhere it is increasing, right? So I need track of two variables. Uh, so another is previous, that is equal to 0. So initially let us have it at 0. So if I greater than 1, oh sorry, if I greater than 0, let's have it like uh, previous equal to array of I minus 1, and current will obviously be uh, current of I. If current greater than previous, I think this logic is fine. You see, like current, if current is greater than previous, and actually we need not check this because we still haven't done anything with it. Um, but we can definitely set this value. So is descending is false in this case, and the break index is this. Um, so but wait, ah, this makes sense. I need to set it false because I don't want it to overwrite itself again and again. So if I set it to false, this if doesn't happen again. Um, Now after this for loop, I need to check if it is descending. If is descending, then I just print everything out normally. Cout array of I I plus plus cout array of I. Let me give a descending example and test out the code. Oh, what did I do here? I'm getting a call somewhere. Uh, what is it saying? Didn't I save this code? Let me clear this out and try it again. Oh my god. One 5 6 5 4 3 2. Okay, let's leave this. These are the values. But you see, like, we got the answer here for descending. Okay, so else, let me see out these. That would be better. Let's have two test cases now. One which is descending and one that is not. Two test cases. First one is 5, 6, 5, 3, 2, 1. 6, 4, 3, 2, 1. The same answer. Next is, I think I need to put an end line after for loop. Next is again 5 test cases. Here, let me give it as 3, 4, 6, 3, 4, 6, 5, 1. So now we have current is 1, which is the last number, 6 is the maximum, 2 is its index. I don't know what 1 is. 1 is where it started ascending, or let me just do the other test case where 2, 5, it's descending for some part, then it starts ascending. It started ascending at 3. Yeah, I can. So what should happen here? 6, 5, 4. 6, 4 is fine. Oh, wait. 6. I did a mistake. Let's go to the thought process of this. So it's not how much is descending and all. There is a difference. We need the maximum and second maximum elements. I only was able to guess that because of the test case I have written there. Uh, 64251. 64251. You see, this is descending till here. Based on our logic, what we'll do, we'll leave this like this, and this will send it to the function which does 5 to 1 thing, right? No, that's not right, because the answer here is we should take L as this and R as this, R as this, and so the final answer would be 565,421. So how to do this? The idea is that if it's not in descending order, uh, we need to find the second maximum, and we need to make sure that the second maximum is in position 1. So L is always going to be 1, R is going to be wherever the second maximum is. Let me explain this with this example. So let's consider this example. 6 2 4, oh sorry, 64251. So here the case is we have the maximum here, out of this list. we take L as whatever the first one is, R as uh, 0, 1, 2, 3. The second max. So we swap them, reverse them. So that would be 6, 5, 4, or 5, 2, 4, 1. This would be the answer. So let's take the case of in between. So anyway, like here the L is 0, R is going to be this index at the end. Here also the L is going to be 0, R is going to be the last index, which is wherever the 6 is. So only in this case, when we have uh, 6 in the start, I mean like the maximum in the start, and we have the second max somewhere else. Uh, but is it right? Is it right? Is it enough that we do it for second max? Yeah, because it said that we have unique elements, right? Distinct integers. Distinct integers. And we can do the operation only once. So that's the best we can achieve if it doesn't exist. So let me go back to the code, revisit, rethink everything. So I don't want the breaking thing. I want the index of the second highest thing. So max, second max. Oh, I can't max to. If uh, I can write it in the else case. Else if current greater than max 2, max 2 equal to current, max 2 index. I need to create this. I think this is it. So if it's descending, that's what we do. Uh, if it's not, what we do is we print max index, max 2 index. Let's see it out. C++ reverse dot slash a dot out. Let's do two test cases. One is 5, 6, 2, 5, 4, 1. Huh? Oh, I didn't break the descending anywhere. That's a problem. Um, what do I do? If he's descending, like I can check this out here. If max index double equal to 0, If the first and second elements, wait, what if, what if, oh my god, this is getting worse. What if the first and second elements are in line? My god, my thinking is getting bad. This doesn't solve all the cases. Like, my thinking is not right. Like, my approach is not right for all the cases. So let's try these out again. Two test cases, 5, 6, 4, 5, 3, 1. Maximum is 6. Max index, max to its index. In this case, this is fine. Like, considering the second one and putting it in front. So here the output would be uh, 6 4 6 5 4 3 1. That can be done here using max 1 and max 2. Whereas let's consider a case that it breaks 6 5 4 1 2. This is where it breaks. Oh my god, I gave a wrong answer. So 6 it took as n. I need to give uh, two more values. How to give two more values? I will give to 1 itself. 5 4 1 to 2 1. How, bro? It must be 5 4 2 1 2 1. But why did it think it's descending? That's the okay. According to this, if the first two elements are in the right index, it's descending. That's where the problem is. How to do this? I have no more ideas at all. I think I just have to practice more. Like this is like getting way bad. Like, not all problems can be solved just like this. Like, I am pretty sure there would be few techniques to solve these kind of problems. And like, I just uh, lost it. How do I say? Like, I no longer want to continue this. I pretty much did this for around one point, I think 1 hour 15 minutes or so. I was able to solve one problem, which is great. Uh, I'll check this out again. uh, maybe few days later after learning few more things. So that's it, I guess. Let me stop it right here.